Last class I have shared two files. One is this one, a linear regression, the Jupyter source file. Then I shared the salary data, the data set also. So we are going to make use of these two files today, and we will work on this one also, the Boston one .csv. Okay. So last class we have seen the supervised machine learning technique, linear regression. Now, linear regression, we have seen that in our last class, we have seen that uh, divided into simple linear regression, multiple linear regression. Okay, so simple linear regression and multiple linear regression are the two classifications of linear regression we have seen. And we have seen that how we can perform linear regression. Now, usually the independent variables, that means the input variables, will be on the x-axis, and the output variables, that is dependent variables, will be on the y-axis. Now we will plot all the data points. So as an example, we have seen the salary data. uh, Here the input is year of experience, the output is salary. Okay, so the input we have plotted on the x-axis, output on the y-axis. Now, when you plot input versus output, you will get a number of data points like this. These red colored data points you will get. Now, in linear regression, so we will try to fit a line having an equation y is equal to b0 plus b1x in such a way that this line passes through, or we will get a best fit line. That is the actual terminology. So we will, uh, just a second. Okay, so we will find a best fit line in such a way that this line reduces the overall error. Now, that is the loss function. Now, the loss function we have seen is the mean square error, MSE, we have seen. Now, MSE equation 1 by n is the total number of samples, data points. Then yi minus summation yi minus yi cap, where yi cap is the predicted one, yi is the actual one. So that means here you can see, here we can see this should be the actual output. For example, this one, this is the actual output. Now predicted one means this one. So there is actually a gap between the actual one and the predicted one. So similarly in this case also, this is the actual output. So when you extend this to the y-axis, you will get the output. So the output corresponds to this data point is this one, but in the line, this is the predicted output. So there is always a gap between the actual one and predicted one in almost all the cases. So that means the best fit line doesn't mean that this line passes through all the data points, but it is a best fit line. So that means the error between the actual one and the predicted one is minimum overall case. Okay, so like this, we will find a best fit line in such a way that the MSE is reduced. So this yi is the actual output and the yi cap is the predicted output. So that means there is an error. Now, using this MSE as the loss function, what we will do is we will try to find out a best fit line in such a way that that MSE is reduced. Okay, so we obtained a line like this. Assume that we obtained a line, best fit line like this. Now using this line, whenever a new input comes, say some 10 EAs, what is the corresponding output? So this is known as the prediction. Okay, so first of all, what we will do is we'll plot the data points. Then we will find out the best fit line in such a way that the error between the actual output and the predicted output is minimized. The MSC is minimized to be exactly. Now using that line, now we have the line here, the same line. Now using this line, whenever a new input comes, it will predict the output. So this is what is happening in every supervised uh, regression type of algorithms. Okay. So what is the input corresponds to this input? What is the output? So this is what is the prediction. Okay. So just a summary of what we have learned in the last class. Now we are going to implement the same salary prediction today in Python. Now for that, I am just opening the Jupyter. Last class I have shared the code and data set also. Okay, so in order to execute this code, this salary data, that is a data set I have already shared, this should be in the same folder. That means, so here you can see I have the linear regression salary prediction in this particular folder, DS and ML class. So in that same folder, I have the salary data. See here, salary data dot CSV. Try to do in this way. Just open the uh, Jupyter notebook and open this one. Now for this, what you have to do is, I have shared you the code in code and data set in WhatsApp group. See this one. These are the salary data.csv and this one MLFDP linear regression. These are the two files you have to download. You download these two files, then you go to downloads, then you copy these files from there and you paste it in C folder or C drive. Go to C drive, then in that C drive you copy it, you paste it, copy from the downloads and paste it in the C drive. So I have the same here in C drive. See DS and ML class. So in that I have all the files related to this particular class. See linear regression salary prediction and the salary data. So both the files are in the same C drive. So make sure this, otherwise this will not happen. Now you have multiple ways, but for the time being, you keep the files like this. Now, otherwise, you can save the data set in some other folder, and using the path, you can call the data set whenever necessary. That is also possible. Now, I think this work is, you have done this work. You have saved the data set and the code, and this is the first cell. So in this first cell, we have called or imported all the necessary libraries. So import numpy as np, import matplotlib.pyplot as plt, import pandas as pd, Now, one more library is required, that is the sklearn library. So that I will tell you later. But for the time being, I am not importing that library. So I will import it later whenever it is necessary. Okay, so as the first step, import necessary libraries. So here one more library is required, the sklearn library. So I will detail you about that sklearn library later, because that sklearn library is the main library from which we can call all the almost all the machine learning algorithms. Necessary codes for all these necessary machine learning algorithms can be easily imported from sklearn library. Sklearn. So I will tell you later, or we will import it here itself. No, this is not necessary here. We will import it later. Okay. Now I am executing this. Okay, this is executed. Now I'm calling the data set or importing the data set. As I told you, this data set salary data.csv is in the same folder in which I have saved this particular linear regression salary prediction file, Jupyter file. Okay, so I'm calling the data set as a pandas data frame. See pd.read csv. Now this read CSV, I have explained already. It is to read the or import the CSV file. Now similarly, if you have Excel data set, then you can use read Excel. That option is also there. But since we have the CSV data file, we are using pd.read CSV. Okay. So as the first step, we have imported necessary libraries. Then we have imported the data set into the object dataset. So this dataset object has the dataset available in this particular salary data.csv. Now let us see the contents by just typing dataset. See, these are the contents of the salary dataset. So how many rows are there? Up to 29. That means 30 data are available from 0 to 29. Now here you can see year of experience 1.1, 1.3, 1.5. Corresponding salaries are 39,343, 46,205, etc. Okay, so this is the input data. This is the data set we are inputting. Okay, so I can show you the data set in C drive. This is the salary data set. See, year of experience, salary. Okay, as I told you, how will you perform linear regression? So here, as I told you, you have to create a best fit line. See, like this. Now for that, we should get the input and output separated. Okay, so for that purpose, so what we are doing here is, so here you can see the input should be, no, the salary should be the output and year of experience is the input. Now we should separate input and output. Now in this data frame, we have both input and output together. Now we have to separate input and output. Now for that purpose, in pandas, there are several methods, but I am using this ilog. This is not the only method. We have multiple methods, and I have already explained you the use of this ilog. So that is the reason why I am using ilog here. Okay, in some other places I will be using some other methods. So for the time being, I am using this ilog. So x is equal to x is the input. Okay, so x is equal to where is the data set we have in object data set. Okay, so x is equal to the data set in data set object dot ilog all the rows, all the columns up to minus 1. So what do you mean by this? All the columns up to minus 1. Up to minus 1 means not including minus 1. So here, which is minus 1th column? Minus 1 means the last column. That is the salary column. Now, up to last column means it will not include last column. So all the columns before the last column. So that is the meaning of this colon minus 1. All the columns before the last column. So that means all the column means here there is only one column before the salary column. So only this year of experience column will be filtered out. So that means this will be the output of that. The year of experience will be year of experience will be the output of this particular operation. Now I am just printing that year of experience. See like this. See. So the X contains the year of experience column only. Okay, so this is the way to take only X outside from the given data set. Now this X we will be using as the input. Okay, so as I told you, there are multiple methods. Now here, this is one method. Now I will show you, you will get the same output. See, if I execute this one, same thing, we will be getting the same thing. Data set of year of experience. That means for 0, sorry, first one is 1.1, second one is 1.3. See, 1.1, 1.3, same thing. Okay, but this is the one I am using. Okay, so this looks what to say good compared to the previous one. This is a data frame, that is why it is looking like this. Previously it was a series. Okay, that's why there were no uh, column names available, but this case it is a data frame. There are multiple methods. Okay, so we will see one by one in our following sessions. So for the time being, understand this is the way to take the input. Then see here you can see there are 29, sorry, 30 rows from 0 to 29, and the column, only one column, year of experience. That is the input. Now what should be the output here? The salary should be the output. Now in order to take out only the salary column, so you can use this particular method. So dataset dot the same thing, we will be using ilog dataset dot ilog all the rows, then minus 1 to the last, minus 1 to the last. So minus 1 to the last means minus 1 means the last one. So last one to, that's all. Only one salary is present as the last one. There are no more columns present. So no need to worry about that. Okay, so only you will get the salary as the output. So you can see that's all. Salary only you will be getting as output. Okay, so instead of this iLock, you can use lock also. Now you try by yourself because we have already worked out different operations using iLock and lock in our previous one of the previous session. Uh, so we have used pandas extensively. So you try out the lock method instead of iLock. You try to use lock. Now when you use lock, you have to use this salary instead of the index. Use the column name. Okay, you can try with that method also. No issue. So this is the output we are getting. So we just now obtain input and output columns. Now you try to do it at your end. Any difficulty you people are following? Any difficulty in following? Please let me know if you are facing any difficulty. Don't just be a listener. So I think
ചേട്ടാ മെയിൽ അയച്ചതേ ഡാറ്റ സെറ്റ് മാത്രമേ വന്നുള്ളൂ.
ഡാറ്റ സെറ്റ് മാത്രം ഞാൻ അയച്ച ഡാറ്റ സെറ്റ് ആണോ?
അതാ അയച്ചത്.
ഓക്കെ ഓക്കെ ഓക്കെ. ഇതും കൂടെ ഉണ്ട്, ഞാൻ എല്ലാം കൂടെ ചേർത്ത് അയച്ചേക്കാം. Okay, so this much time is enough, I think. Then now after getting this input and output, now what is the next step is just try to plot the input versus output, scatter plot. So plt dot scatter, plt means the matplotlib we have imported already. See, matplotlib dot pyplot as plt. So that plt we are using here. So plt dot scatter of x comma y, color is equal to red. Now x label year of experience, y label salary. If you give like that, you will get a scatter plot like this. X axis year of experience, y axis salary. Now these are the data points x versus y. So this is the graph I have just now here I have shown you the plot of the scatter plot of input versus output. The same plot here. Okay. Then after this, the linear regression part will come. Okay. After this, the linear regression part will come. Usually, we will be doing some scaling operation also, but this time I am not doing that. So we will do the scaling operation in our next hands-on. Okay, normalization. So we will not doing that thing here. This is just to understand the process. That's it. Okay. So next thing is we want to split the input and output into training and testing set. So this thing we have already discussed. The entire data set should be divided into training set and testing set. Here we have explained it. So the entire data set should be divided into a training set and testing set. Now training set contains X train and Y train. Similarly, test set contains X test and Y test because here the input is both X and Y. So train means X train, Y train. Test means X test, Y test. So we need to split the input into train set and test set, both input and output. So X train, X test, Y train, Y test, separated by comma. Okay, so we have actually a specialized code available, train test split. This code is available in sklearn library, sklearn. Okay, sklearn means scikit-learn. So that is the, so I will show you. See, sklearn means scikit-learn. So this is the machine learning major machine learning library available in Python. So you can call this sklearn in Python. Scikit-learn, SCIKITLEARN. So this is a library. Almost all the machine learning tools are available in this scikit-learn. So we are going to make use of this scikit-learn, and this train test split is a specialized code available in this sklearn. So scikit-learn is short known as sklearn. Okay, so we should import sklearn. Now here we are not importing the entire sklearn library. Okay, so note this point. We are not importing the entire machine learning, entire sklearn library. Instead, we are calling only this particular train test split. Now for that, here is the syntax. From sklearn dot model selection, this is a sub library, import train test split. So this is the way to import a specific code from a library. But here what we have done, we have imported the entire NumPy library as NP. We have imported the entire matplotlib.pyplot library as PLT, entire pandas as PD. Okay, this is the way to import the entire data, entire library. But here I am not importing the entire library. I am importing only the specific train test split. Okay, so this is one way. You can import the entire library at first and you can call it here. That is also okay, no issue. But here I'm showing you a different way, that's all. Okay, so from sklearn dot model selection, import train test split. Now this code will split the x and y into x train, x test, y train, and y test. With the ratio test size is equal to 1 by 3. That means 0.33, 33 percentage. Or instead of this, I can give 25 percentage, 0.25 or 20 percentage. So test size is 20 percentage, points 2. So I told you in the last class, the entire data set will be divided into training set and testing set with a ratio 80-20, 70-30, or 75-25. So here I am splitting in the ratio 80-20. So test size is 20 percentage. So that is zero point 0.2. Okay, so this is the way to split the data set into training and testing set. Test set contains 20 percentage of data. Okay, so I think this is enough. Now here you can see if the data set contains 30 observations, see you can see that the data set contains 30 data. So up to 29, that means 0 to 29 means 30. Now, out of 30, 20 percentage means, so we will see it, we will see it. Okay, we will see it. Now I am executing this, executed. Now let me see the X train. So we will see how many data are there. X train contains, see, this many data. Then X test, this many data. We'll see 1, 2, 3, 4, 5, 6. That means the 20 percentage. Okay. So remaining data, train data, X train. Now you can see here the data set has been split into train and test. X train, X test. But as a result of this operation, the order is different. It has not taken in a definite order. It has taken the data set in a random order. Okay, so this is the speciality of this, or the train test split takes the data in that way only, in a random order. That order is not preserved. Okay, whenever you execute it again, that means if you execute this instruction again, and if you see the X train, then also the order will be different. It is a random order. That's all. Now we execute this train test split. So that means we have given the data in a definite order 0, 1, 2, 3, 4. But after splitting, see, there is no definite order. First, it has taken the 18th data, then 18th row, then this one, 11th, then 9th, then 1. First. Okay, in a random order, the data set has been split. Okay, so this is X train, X test. See, you can see test data set contains 6 data only. That means 20 percentage of 30. Remaining 80 percentage is there in the X train. Now, similarly, you can see the Y train and Y test. I am showing only Y train. See, Y train contains Y means the salary only. So you can see Y train contains this many data. Similarly, uh, if you see the Y test, you can see the corresponding data, 6 data. See, 1, 2, 3, 4, 5, 6 data in a random order. So the entire data set that contains 30 number of data has been divided into test and train data. Test data contains 24 data and train data, sorry, test data contain 6 data and the remaining 24 will be there in the train data. Any doubt up to this? Now, using this simple code, simple line of code, you can split the entire data set into train and test data sets. Okay, so both x and y should be splitted because in the supervised case, we will be feeding both input and output as the input to the machine learning supervised algorithm. So that part we have already seen in our one of the previous sessions. Okay, so we have split the data sets into train and test data sets. Now, what is next part? This is the main part. So we are calling the linear regression. So this is the particular code for implementing linear regression. See, linear regression. This is the function to be called. Now this function is available in the same sklearn.linear model. A linear model is a particular sublibrary which contains this linear regression function. From sklearn.linear model, import a linear regression. Now, that imported linear regression function you have to use here, and function we are taking into an object named regressor. This function we are taking this function into an object named regressor. Now we want to apply this function on the dataset. What dataset? Train and X train and Y train. So regressor dot fit of X train and Y train. That's all. Regressor dot fit. Fit means we are fitting that regression, linear regression onto the input. So here input is X train and Y train. Why this X train and Y train? Because I have shown you already. We have discussed what is the input to the regression or the machine learning. X train and Y train. This is the training phase. Okay, we have to feed both X train and Y train. The same thing we have done here. So regressor dot fit of X train comma Y train. So that means this much is okay or this much is necessary enough. So we have completed our linear regression. Okay. Now what we have to do, we want to do is we want to know the intercept and coefficient. That means the B0 and the B1. Now print regressor. See, linear regression is available. That means the line is available in this regressor. Now what is the intercept of that line? What is the coefficient? We can print. Name regressor is not defined. Oh, okay, okay. I have not executed this. Sorry, I have not executed this. So first of all, I am executing that linear regression. Now I am printing the intercept and coefficient. See, this is the intercept. This is the coefficient. Okay, so this part is not important for us, but just I have shown you the intercept and coefficient. Okay, then this part is not important for us. Now, what is important for us is the prediction. Okay, so test value before that testing should be done. So, test data set is available in X test. Okay, now you have to give regressor dot predict. So, regressor inside the regressor we have our line best fit line available. That function is available. So that dot predict of x test. Now what is the prediction, corresponding prediction? That will be available in y predict. Now this y predict should all sorry. Okay, I will execute this. We are getting this y predict here. Now I am printing that y predict here. So these are the predicted values corresponding to the x test. Now let me print the y test also. Y test means the actual output. Y predict means the corresponding predicted output. Now we compare the actual output and predicted output. See, actual output should be 11,000. Sorry, 1138, 1 lakh 13,812. But the predicted output is 1 lakh 17,055 point something. That means that much difference is there, that much error is there. So that is the one I have shown you here. There will be an error. See, here I have shown you this is the actual output, this is the predicted output. So definitely this error part will be there. Okay, so this is the case we are getting. Now for this particular actual output 60150, this much is the predicted output. So that error is high here. See, it is 53. Here it is 60. So error is high. But you see this case 91,000. It is 98. Again the error is high. Now why the error is high means here we have given only 30 data. Now usually in machine learning case we should give large number of data, more than 500 or 1000 data we should give. Then only we will get the error reduced. Okay, so this is just for the explanation purpose. I have given only 30 data. Now, in order to get this error reduced, we need to feed maximum number of inputs. If you feed maximum number of inputs, like as I told you, more than 500, you will get this error reduced. For the time being, understand this is the actual output. Y test contains the actual output. Now, for this purpose only, we have taken the test data in order to test at the last. Okay, so we have given x test as the input and y predict is the corresponding output. Now you know corresponds to x test there is actual output y test. That when you print here you can see y test is here. This is the actual output and this is the predicted y predicted output. Now you can see there is an error between actual output and predicted output. This error should be minimized. This error should be minimized. Okay, but here we are getting some error because we have fed only a limited number of data. Now if you increase this 30 to more than 500, you will get maximum accuracy. So here you can see the error is high. Now if you feed maximum number of inputs, the error will become very much less. Now let us plot the x train, y train as we have done already, x train, y train, and the corresponding line. So let me see, this is the output. So x train, y train we have plotted as data points, red points, see this one, the same thing, x train, y train, see. So here x and y plotted. Instead of that, here we have plotted x train, y train. That's so. That is the only difference. That is the red plot, scatter plot. Now, along with that, we are plotting the output of this particular operation also. That means the prediction operation. Regressor dot to predict of x train versus x train. Okay, so when you plot that, you will get a graph like this. So this shows the uh, year of experience, salary, the data points, training data points, and the corresponding best fit line. See, you can see there is for this particular data point, see this particular data point, the error is large. Okay, usually if you give large number of data points, this error will come down to uh, a minimum level. Okay, anyway, this point also is not important for you. This is just to plot. So don't get confused. Don't think that it is very difficult. This is not required. This is just to show you the graph. Okay, so I have plotted two graphs here. One is the X train, Y train scatter plot. Another one is the, see, as I told you, this line is there in the regressor. That dot predict X train versus X train. Both the graphs have been plotted here. That's all. Okay, similarly, the X test and Y test testing data. What is the graph? That also, if you want, you can visualize. That's all. Testing data, as I told you, less number only. So less number of data points and the corresponding line. Anyway, this is also not necessary. So what is necessary is we should predict, because what is the intention of this particular machine learning operation? To have a prediction. So that means um, you can see in the data set, see, year of experience means 1 year, 1.1 year, 1.3 year. See, we have up to 10 year. Now, if a new employee comes with an year of experience of some 14 years, what is the salary he is going to get? That is a prediction. New value. You have to give new value. See, this is the case. This is the case. As I told you, just now we have created the graph, the line, the linear line we have created just now. We have plotted the line also here. Here we have plotted the line. Okay, for both the testing and training data set, we have plotted the line. Okay, now you give a new input having 14 year of experience. That is not available in the data set. See, data set contains only year of experience up to 10.5. Now you are giving a new input. The year of experience is 14. Now what is the corresponding output? You have to find out. Okay, so this is the operation we are going to do now. So that means regressor dot to predict of 14. Regressor dot predict of 14. So that is taken as the new salary prediction, and I am printing it. Print the predicted salary of a person with 14 year of experience is, comma, the output new salary prediction. This one. Now, if you this is 14 years, not 12. If you print this, see, the predicted salary of a person with the 14 years of experience is this much, 1,55,110 point something, based on this particular graph. Okay, 1,55,000. You can see in the data set up up to 10.5 year it is 1,21,000. So that means when you give 14 year of experience, anyway, you will get a salary more than this. Okay, you can see you are getting 1,55,000. Now, if you give a different year of experience, say 11 year, Here also 11 year. Now what is the output? See, 1 lakh 27,000 something. That is also, I think, larger. See, it was for 10.5 years, it was 1 lakh 21,000 872. But for 11 years, 1 lakh 27,000. It was 1 lakh 21,000, now increased to 1 lakh 27,000 for 11 year of experience. So this is the way to have prediction for a new input. Now this salary will not be that much accurate. Why? Because you can see directly from here the prediction is somewhat erroneous. That means that for that purpose only we have done the testing. For that purpose only we have done the testing. Now during testing we have seen that the predicted value is somewhat uh, different compared to the actual values. That means that much error is there. Now how to reduce this error? Our aim is to get an accurate model. So how to reduce that error? One way is by giving large number of inputs. Okay, so using that we can reduce the error. Now let us see the performance parameters. That is very much important. Performance parameters. So here mean square error is one performance parameter, MSC. Okay, so when you give y test versus y predict, because see here we have given y test. See, this is y test and this is the corresponding y predict. Now when you give both these things, what is the average error, mean square error? When you give y test and y predict, you are going to get the MSE as this much, mean square error, large value. Okay, so that MSE mean square error is available in again the same sklearn library. So from sklearn dot metrics, see this time the sub library is metrics. Okay, so from sklearn dot metrics import mean square error. Now after importing you have to use it. So mean square error of y test comma y predict is this much. Now one more parameter is there, R2 score. So I will tell you what is that R2 score later. Okay, so again if you import that from metrics, from sklearn dot metrics import R2 square, use that R2 score. It is R2 score actually, not R2 square. Okay, R2 score, same y test and the y predict you give, you will get R2 score like this, 0.91. Okay, the ideal value of R2 score is 1. Okay, so this is the performance of the algorithm we or the model just now we have created. Now about this R2 score and MSC, we will see some more details in our next session or the session that is going to come after this hands-on. For the time being, understand this is the R2 score, this is the MSC. MSC already we have seen, but anyway, we will see it once again. Any doubt up to this? Now, what we have to do is you have the model available now. Where is the model? The model is available in regressor. Model means the line. So, the line is available in regressor. The line is available in regressor. Okay. Now, that model you have to save somewhere, and that model you Hello, is it audible now?
Yes, sir. Yes, sir. Okay, audible.
Okay, okay. So this, what you have to do next is this model that is available in regressor, you have to deploy somewhere. Okay, you have to deploy this. Deploying means you should deploy this to a cloud like Amazon Web Service, Microsoft Azure. So you can deploy these models to cloud, and you can get a URL also. Now using that URL, whoever want to give an input, they can give the input and they can get the corresponding output. That's all. That is a web app. We can say we have created a web app in that way. Now, in order to create a web app, what you have to do is you save this regressor model somewhere. So I will show you how to save the model later. You save the regressor model and you take that model and deploy in some cloud. From there, you can obtain the URL, the website address. Now, using that website address, you can have the prediction online. Now, if you want to sell it to somebody, you can sell it to the required person, and that person can make use of this URL, and he or she can have the prediction. Okay. Anyway, that part we are not going to do. The deployment, you can do it by yourself. You can have an account in Amazon Web Service or somewhere, and you can deploy it there. Now, for that, you have to create a HTML or the user interface also. You have to create a user interface using HTML or any of the front end technologies available. You can create a front page. Then, in that front page, you can connect this regressor model there. So whenever you give an input in that front end, the regressor model will be automatically called and have the predicted output there itself. So like that, you can create a user interface and you can deploy in the cloud storage. So any doubt up to this? Now this is simple linear regression. As I told you, you can have simple linear regression and multiple linear regression. Now, why it is known as simple linear regression means, so here we have used only single variable as the input. See here, x contains only one variable, that is the year of experience. X contains only one year of experience column, only one variable. Okay, so that is why it is known as single or simple linear regression. So that we have seen in our previous class, simple linear regression and multiple linear regression. And now we will see the multiple linear regression. So before that, any doubt up to this? Now, regarding these graphs and all, no need to worry about these graphs because these graphs are not required for you. This is just to show you the input and corresponding output, that particular plot. For that purpose only I have created this graph. This is not necessary. What is necessary is up to this. Separate x, separate y, split x and y into train set and test set. Then train the model. So this particular operation is known as model training. Now for training the model, you call the linear regression function from sklearn dot linear model. Now fit that model into the X train and Y train. That's all. Now the regressor will contain the model. Okay, these two lines are also not important. Now what you have to do is you give the test data, get the output. Now that output you compare with the test output, Y test. Now you see the similarity or see the difference. If there is any difference, that is an error. See, this is the actual output for this particular 23rd row, but we are getting this is the predicted output. See, there is a difference. That difference is the error. So this is known as testing phase. Now, in order to have the tested output, that means the performance output, performance parameter, we are giving both the white test, actual output and predicted output as the input to the MSE function, mean square error function. Now we are getting the performance parameter as the MSE or R2 here. Now you see these values. Now if you are satisfied with these values, you can go ahead. If you are satisfied with these performance parameters, you can definitely go ahead, no issue. That is the importance of testing. Now, once the training and testing is done and you are okay with the performance, you can say that you obtained a good model. Now, using that model, you have the prediction.